Hello, everybody. Thank you so much for joining today. I'm going to go through some housekeeping items first, and then we'll go ahead and start with the presentation. My name is Jane Rothstein, and I'll be your moderator for today. Our webinar today is our 250-plus database products. Are you running the right one? And we're really excited to have our featured speaker from Forrester Research on the line as well. You have all been entered on mute, but if you have any questions throughout the webinar, go ahead and enter them on the right-hand side of your screen. We will go ahead and address them at the end during our Q&A session. We have 3 industry experts speaking on our webinar today. Our guest speaker is Noel Yuhanna, who's the Principal Analyst at Forrester, Peter Goldmacher, who's our VP of Strategy here at Aerospike, and Alvin Richards, who's our VP of Product at Aerospike as well. So our agenda for today, we're covering some awesome topics here. We're going to have Noel start with industry overview and trends of the market, and then how to choose the right database. We'll have Peter come in and talk more about the evolution of data and give you some real-world use cases where speed at scale really matters. And then Alvin Richards, our VP of Product at Aerospike, will come in and give you a bit about the architecture overview. And we'll finish up today with a quick wrap-up and a Q&A where we'll answer all of your questions. So I'll go ahead and pass it on off to Noel.
Thanks, Jane. I guess good morning, good afternoon, folks on the call. This is Noel Yuhanna, Principal Analyst with Forrester Research. And today I'm going to talk about choosing the right database. It's actually a very interesting discussion to have because I get a lot of inquiries from clients, and you know, I speak to about 3 to 4 customers every day from different industries, whether they are the banking sectors, the oil and gas, and retailers, telcos. And what's interesting is that, you know, the data management, the database management, data management, things have been changing quite rapidly, actually, over the last 5 years, if you can well imagine, right? And we are building these new types of applications that need some different types of formats and structures and storage and processing and access, which lends itself towards thinking about, no, do you really have the right database actually? Because one size doesn't fit all for some of these requirements coming down the pipeline. So I'll talk about where is the industry today in terms of databases, in terms of deployments of these, where are some of the gaps, you know, what kind of trends we see out there for new types of applications, and also deploy across different types of scenarios in the industry, right? So this is actually a very important, I guess, kind of a platform which customers should look at. And I would recommend, you know, that if you're putting a database strategy together, definitely consider something which you haven't done before. You know, think about databases that have not been part of your data platform, actually. So I guess if you were to look at it in terms of the whole notions about where we are, next slide. I guess, you know, the business growth and speed are driving this new applications and data requirements that's changing the way we store, process, and access data, as I mentioned. You know, there is obviously the speed of the businesses today are amazing. We are developing these mobile applications and the web-based application and the cloud-based applications that need a faster database, actually, right? And some of these applications are like in real time, like in milliseconds, right? No, things are different than what we have done 10 years ago, right? I mean, we were building more CRM applications and ERP applications that didn't really need milliseconds of response time, actually. But what if you are going to address it like a mobile application? And in the mobile application, I guess, you want to be able to service customers in your real time. That actually is some of these customers, like in retailers and banks and insurance companies are starting to do, right? Next slide. So I guess, if you look at it in terms of the data volume, 90% of the data has been created in the last 2 years. 90%. Wow. And if you look at it, we are running into zettabytes. That's almost like 21 zeros, actually, in zettabytes. I don't think it fits into my calculator, actually. but zettabytes is a lot of data, I guess, right? So if you look at it from where we have come, we have come a long way. And these volumes have grown so much significantly in our infrastructure, in our IT organizations, that have become so difficult to manage and administer and tune and optimize these databases. And I'm sure in your organization as well, you're running lots of data into probably terabytes, maybe, or tens of terabytes, or even hundreds of terabytes for data warehouses, for analytical applications, for transactional applications, and what have you, right? And I think, we're not stopping there. We are eventually going to capture more and more data. We're going to actually have a really a platform that actually would be serviced for various types of newer applications as well. So the data, I think, volume is just going to be increasing significantly. In fact, if you look at your iPhone and Android, right? I mean, they're already starting to move into terabytes actually soon. And if you're going to have terabytes on your iPhone and Androids, what about your databases actually? They're not going to stop and not only have terabytes, they're going to have hundreds of terabytes, right? Okay, next slide. So if you look at database management challenges, they have grown significantly. When I speak to customers from different types of industries, they all complain that, hey, we got these hundreds of databases, thousands of databases. It's difficult to provide a complete modernization of these databases. Some of these applications have been built old, kind of a legacy applications, and they're using databases which haven't yet innovated for the last many years. So what it implies is that, all of these creates a bigger challenge for IT. In fact, IT is spending a lot more time and effort trying to manage these databases, actually, which are thousands of these databases. There's one customer that I was speaking to. They have more than 75,000 databases. Now, when you try to manage 75,000 databases, it becomes a challenge, especially when you're trying to fit applications with the same database platform. Well, your application is changing, so should your databases, right? In terms of your structures, your processing, your administration requirements, and the cost as well, right? So all of these things should be changing as well. Next slide. When you're using the wrong database, I guess, you waste resources, you increase the cost and slow down new application deployment. I mean, sometimes, you're trying to run, I've seen organizations running some newer types of applications, maybe web-based applications, using some traditional database technologies. And guess what? All of a sudden, when they deploy that application on this database, all of a sudden the CPU goes up like 100%. Whoa. And you're running like 100 users with it, right? That because the reason why the databases aren't optimized. For example, unstructured data. What about semi-structured data, right? If you try to put semi-structured, unstructured data in some of the traditional databases, you are not running in a very optimized manner. Guess what? Your CPU is going to spike. Your resource consumption is going to be more. Your administration requirements are going to go. You're going to buy more hardware now. You can spend more dollars actually trying to buy more hardware to kind of run these applications, these modern applications that demand data right away, right? And it's not just about unstructured data or semi-structured data, but there's some complex data structures as well, right? And then you want data a lot quicker, not like 5 seconds later. I want a response back. Sometimes I want response in milliseconds. Yeah, how do you account for that, right? Putting more memory sometimes does not help because the architecture of these databases aren't very well aligned towards delivering better performance, right? Next slide. Data management, pain points have intensified. If you look at it on the left-hand side, you got data management and you got distributed data management. Now, in data management side of the house, you got a growing data volume, I guess, which is obviously a bigger issue, which I mentioned. Every organization runs through that data management challenge with the volumes growing into terabytes and petabytes. But they also need this data in real time. Imagine your iPhone and Androids having emails coming like an hour later. It's not acceptable in this era of mobile computing. What about your enterprise data? You want this data like today. I don't want yesterday's data tomorrow. I want the data like now. Real time is becoming a big thing. In fact, most of these applications are driving towards real time. How is your database actually addressing that need for real time? Think about it. Putting cache and memory is not sometimes the answer towards delivering real time, right? And obviously security concerns are there as well, right? I mean, people have got more security concerns today than ever before. You got to manage, optimize these databases so that you are meeting the compliances for PII, PHI data itself. Growing complexity of systems, increased HA requirements. People are wanting 100% uptime of these databases today. 5-10 years ago, we were okay with, 2 nines and 3 nines are good enough, but not anymore. We are running global operations today in most businesses. We can't afford to go down. And even if we go down, you probably go for a very, very short duration. But most people are looking for 100% availability of these, right? The 100% uptime. So that's a big concern. Underutilized servers, there's obviously driving towards enhanced SLAs. On a distributed data side, you actually have integration issues. You got administration challenges, duplication data, performance scale, synchronization, you name it. So if you look at it, the trends for data management and distributed management have increased significantly. So I used to work in IT organization as well myself. I know exactly how things were actually back then. But the thing is, today it's different because you're dealing with so many different types of applications, so many different types of requirements. You really have to look at in a broader perspective of how things could really benefit, right? If you look at the 4 key trends that are impacting database strategy, so we talked about where the current situation is today, right? People have got challenges. That's good, but I mean, I guess we still have a bottleneck with all of these challenges. We got to really improve our performance and scale and availability and all the good stuff. But what are the trends we see which are impacting database strategy, right? What are customers thinking about? And if we were to put into 4 buckets about the trends on, that's related to database strategy today, it's 4 things. Number 1, next generation applications, right? People are building these new types of applications, social network apps, real-time, line of businesses, big data applications, mobile applications, and others, right? And that actually is something which it obviously creates a bigger platform as well, right? You need to have a strategy. How are you going to address this need for these new applications? And I'll talk a bit more about this. The volume, velocity, variety, as everyone talks about it, has grown significantly. Larger data warehouses, unstructured data, administration challenges, scale issues. This is the ongoing issues we have been having, I guess. The only thing is that these issues have become worse today than what they were 5 years ago or even 3 years ago, actually. And I got global applications that need global availability of these, 24/7 availability, 100% uptime. And also budget, right? I think every organization today is obviously controlling their budget, especially when it comes to data management, databases, right? No, people want to do more with less. Automation is the key, right? And obviously you need to have more optimized systems, which obviously drives a critical strategy as well, right? So these actually obviously are creating a bigger issues. Now, if you look at it, the new business requirements are making older database approach insufficient. If you look at some of the business challenges of this, right? They need more real-time, delivering more solutions quickly, deliver more scalable solutions more quickly, but also being more effective. And from a technology perspective, it's all about increasing volumes, the availability and number of users, right? So to summarize that, hey, this is the new requirements we have, right? Which obviously is a major challenge. Now, if you look at it, some of the new applications I mentioned, what are these new applications? I'm sure you must have heard the age of the customer. It's about personalization. It's not putting customers in a bucket, right? Hey, this is what we used to do actually for many, many decades. Like I said, put customers in a customer like a CRM. But we want to individualize and give a personalized experience to the customer. I'm sure in your organization you have customers. That's how you get revenue, right? And each of these customers have to be personalized. Imagine if you had 1 million customers. And each customer needs to be, you need to really take care of each and every customer in terms of personalization. What do they like, dislike? What are they likely to buy this product? Not about collectively, not the 1 million customers, I'm talking about each and every customer. So that actually changes everything actually. Why? Because you just need to know more data about this customer. Not only customer data, which is sitting on your on-premise data, but also data sitting in the cloud actually. And all of this has to be integrated in real time as well. Like imagine if a customer calls in, right, to your organization, you should be already knowing a complete view of the customer, 360-degree view of the customer, right? Like what are the likes, dislikes, and all. Today it's not the case. When you call up some company, they may not even know exactly what you ordered a year ago actually, right? Some of the companies do though, right? So that actually is the differences out there. IoT, Internet of Things, is a big thing where I think there's a growing adoption of this, where we're trying to deliver more relevance of analytics towards sensor data, towards all of these consumer sensor, but industrial sensor data as well, like machines, right, which needs to actually operate 24/7, right? Real-time analytics, 360-degree view of the business, products, global transactional applications, gaming, fraud detection, you name it. I mean, if you look at some of these applications, they never existed a few years ago, right? I mean, these are different. This is not what we built 10 years ago, actually, right? None of these actually. We were talking about CRM and ERP, spending the whole year in IT organizations trying to do that, right? So things are a bit different in this regards. If you look at the age of the customer, I mean, in other words, this is a transition we've gone through over the last 20 years, right? Every 20 years is a business cycle which reinvents itself to catering to a particular segment of the market, right? Like age of the manufacturing from the 1900s to the age of distributions, toward the age of information, towards now the age of the customer. We are empowering the business users or the buying decision makers or the consumers, like Macy's and Salesforce and USSA and Amazon actually are doing, right? I mean, these are trying to cater to the customers in a more effective sense. And customer is the king today. I mean, they have access to all the information about your product and services actually, which is scary actually, right? And so what happens, I guess, is that churn can happen very quickly. If you're not aware about what kind of data, what kind of information do you know about this customer, and is this customer likely to churn? In fact, some of their customers actually are looking to their friends and families and peers to getting information about additional products and services, right? They may actually move their subscription model or their services or being a customer to somewhere else actually, and that's a lot easier today than doing before, right? Because of the internet, I guess, right? So how do you actually do this, right? And the way customers are building some of these, like retailers from I speak to, they are building these new applications using some modern database. I'll talk about this modern database, what it means, this modern database, right? And because you can't really use traditional databases sometimes for these newer generation of applications, because you're requiring a lot of processing to happen, more complicated processing to happen, more real-time processing to happen, which obviously creates a challenge in most regards. If you look at it in this Netflix, right? I mean, Netflix have gone through, again, a very a kind of a transition for the last 15 years from where they were shipping those DVDs and videos and into becoming more digital organization. Today, they're giving you recommendations, which they are very accurate on in terms of recommendations. And it's not about recommendations about the 50 million subscribers in collective sense that, hey, by the way, you guys will like Die Hard, this movie. But actually based on your viewing and based on other people's viewing, and for each and every customer of those 50 million customers, right? Think about it, right? I mean, it becomes very complex trying to do this actually. In certain, it's not a select statement or a SQL statement which will be able to give you this answer actually, right? It requires a bit more complex processing and a high-speed database platform, which I think is very important. IoT, as I mentioned, this is huge. We got data coming in from all the sensor data. Cisco predicts 50 billion devices connected by 2020. In fact, Forrester is estimating about 30% usage of industrial IoT in manufacturing today, and it will double by 2019. So about 30% adoption already in the IoT for manufacturing. But this is a huge area, and all these machines operate obviously 24/7 sometimes. You want to be able to act upon this data a lot faster than what you've done in the past, right? So this is an important area of focus as well. Amazon, if you have an Amazon Prime user, but it's actually, you'll see that there's a lot of things that go with Amazon. From the time it puts the orders in, to the carriers, to notification, all those things. It's a very complex system actually they have. Yet they deliver most of the time, the packets or these deliverables on time. So it's a very complex thing, and especially with Christmas coming in around the corner, it becomes more kind of difficult to do that. And Amazon actually has a lot of these predictions they're going to make about how much carriers are going to be used today versus tomorrow, and what kind of goods are going to be used. They're making all these predictions as well, and this is a very sophisticated kind of analysis you got to do, right? Data kind, if you know these guys, actually, they're actually more of a, the big data kind of a provider, I guess, or analytical provider, and one of their, projects have been on this New York parks. There are 100,000 trees in New York parks, and they want to be able to understand the behavior of storms and these trees. What is the likely of these trees getting impacted by a storm, and what is the risk of that, right? And because it may disrupt, the people, I guess, lives in New York City, I guess, just because the tree goes down, I guess, right? So this is actually a very complex thing again. You have to know about the storms in real time, as well as you have to know about these data from all these trees, historical data as well. So it's a combination of this very interesting data. Supermarket predicts exact date customers will return, and what they will spend within $10 for 19% of this customer. Again, very complex kind of a prediction for these environments. So, I mean, I guess, it comes back to the fact that, what does this mean, I guess, right? Your database strategy needs to include NoSQL. And why NoSQL? If you look at some of the new application requirements we talked about for these applications that are coming down the pipeline, they are looking for optimized unstructured data. I mean, you can run unstructured data in traditional databases, such as relational databases, but they're not optimized. What it means is that you're going to spend more resources, memory, and disk, and administration trying to do this. NoSQL actually is more optimized. So when we speak to customers who are deploying it in the banks, in the insurance companies, the retailers, the telcos, some of these use cases go very well with NoSQL because they're optimized for those, like unstructured data as mentioned. What about scaling to petabytes, right? Again, we've seen NoSQL actually scale to petabytes. You really come across scenarios where relational databases are scaling to petabytes, right? Millions of users, whoa. Normally we heard about thousands of users. What about millions of users, right? Again, complex kind of requirements. NoSQL does a better job in some of these requirements. Complex data relationships that needs to tie data across many different interrelated data data relationships, which actually makes it more challenging. Imagine trying to do a 20-table join. Right? How long is that query going to look like in a SQL, right? Sometimes, things can be done a lot simplified way, like in NoSQL, actually. Right? Flexible schema, right? Again, that's another thing which I think NoSQL actually has a better handle in terms of having a more flexible schema. I want a column which is a few bytes. I want another column which is a terabyte. Right, okay. Can I have a terabyte column, Well, relations may not have you a terabyte column, actually. Extreme performance, easy to deploy, use, lower cost is obviously another factor. We tend to see, customers who are doing NoSQL are saving money than what they've done from relational. Some claim 20% saving, some claim 50% saving, and some claim even more, actually. The savings will all vary depending on the type of architecture you're deploying, the amount of data the amount of databases you have deployed in the past. Those things would actually matter as well. Horizontal scale out, sharding. Can I have automatic sharding across these data? Most of these relational databases don't shard out. You run it on a single server and that's it. Sharding out of this becomes very complex. And what about automatic sharding? Can I put it across 10 nodes automatically? Well, I can program it in Java, which may take you 6 months. What if I can do that in a second in NoSQL? Right? That changes everything. So, and it's all about faster time to value, which I think is very important. So, all of these things could be done in relational, but you're going to spend 6 months, a year trying to do this optimization with your applications being built. But you don't have 6 months because your competition is already ahead of you, right? So you really have to jump and then start to look at solutions that's relevant. Relational databases have their own space and own place in that, but NoSQL, I guess, are some of the modern requirements for these applications, as I mentioned. If you're doing age of the customer, IoT, which require millisecond response times, these are things which really benefit for those environments. Definitely NoSQL helps a lot. With that, I'd like to thank you, and I guess hand it over to Peter.
Hey, thanks, Noel. Good morning, good afternoon, everyone. My name is Peter Goldmacher. I'm VP of Strategy at Aerospike. And what I'd like to do is talk to you a little bit briefly about the evolution of data from our perspective, talk to you a little bit about Aerospike specifically, and then hand it over to Alvin Richards, our VP of Product, to tell you how we do what we do. So if I go to this next slide, this is our perspective on the evolution of data. So from about 1970 to about 2010, which is 40 years, you really had one innovation in the database, and that was a transition from a hierarchical to a relational database. And that period, I think most IT folks defined data as business data. So most of the data people were looking at were data about how do I run my business? How do I keep track of my financials? How do I keep track of my supply chain, my manufacturing data, and my people? And in that paradigm, a relational database is perfect because you write a relatively rigid application, you explicitly define data, and you build your database to support that application, and there isn't a whole lot of change that happens. So in that world, a relational database is great. But when the internet burst onto the scene, one of the impacts that is profound, especially in the database world, is we really started to redefine what we mean by data. So data is no longer business data. Data is basically any time you transition something from analog to digital, that can be captured as data. So it can be your mouse clicks, it can be your GPS data from your device, it can be the things you're browsing. Everything now goes from analog to digital, and the opportunity to capture that data and leverage that data created entire new industries. We always talk about what's going to be the first big data company. Well, I think Google is the first big data company. These are guys that said, hey, what if we index the internet? And they certainly never would have done it on a relational database. They would have gone broke buying it, and it wouldn't have fulfilled their needs. So they built their own database. And what we see now from an IT perspective is the database isn't an inhibitor anymore, it's an enabler. And what you have to think about as an application developer is, what product am I trying to build? And then you have to look at the 250 plus databases in the market and say, what database best supports the application I'm trying to build? So really, the database has transitioned from a product to a category. And as an application developer, you need to understand the database better than you ever have before, because your default can no longer be a relational database. So one of the things we think about at Aerospike is we think there are enough databases on the market that are trying to be general purpose databases and trying to be all things to all people, and it's the breadth versus depth argument. So most of the best known databases are going with the breadth approach, but at Aerospike we're going with depth. And what we really want to do is build a database for people whose applications require speed at scale, and that's our slogan, that's our rallying cry, and that's what we do. So we're not a general purpose relational database replacement for commodity applications like content management or website. We really are trying to enable new kinds of applications that are really mission critical. So if I go to the next slide and I look at what are the common characteristics among all our users. The first and I think most profound is 100% of our customers use our database in mission critical apps that require 100% uptime. These applications are revenue generating, direct revenue impacting applications, and this is in ad tech, in risk and fraud and financial services, and in telecom. These are not commodity workloads that uptime is a factor. These are mission critical workloads where uptime is the factor. And that's really, really important to understand. One of the things that our customers all have, another thing our customers all have in common is they have time-based SLAs where they have to deliver results in a very short time frame. In the ad tech world, that's sometimes as short as 10 milliseconds. In the fraud world, it's about 3/4 of a second. So what they're trying to do is they're trying to reimagine their applications, make them more robust, make them more functional, make them more accurate without sacrificing at all the time-based SLA for millisecond response times. Two more things our customers have in common is they're mostly dealing with very large data sets. We have multiple customers dealing with 50 terabyte data sets. We have a couple that are on a fast path to over 200 terabytes. And we have many customers doing 2 million transactions per second. We have a couple customers doing 4 million transactions per second. These are really, really big numbers. And the only way we're able to support speed and scale is because that is our explicit and our exclusive focus. So if you are working on a application where you need speed at scale, we like to think it's the only game in town. One other thing I want to address really quickly, and then I'll talk to some use cases because I think that really brings these points home, is the reality and the secondary selling point, which is we are actually significantly cheaper than most alternatives out in the market. We do a lot of business where when we sell our product, they love the functionality and they love the speed at scale, and then when we show them how to deploy it, and they realize that oftentimes they can get 90% cost savings, 90% cost savings, not 10%, 90%. It's really an eye-opener, and for a lot of our customers, that's the icing on the cake. So let me switch slides and talk about a couple use cases. And the first use case is ad tech, and this slide has a lot of detail on it, and you'll have access to these slides later and you can read through it on your own, but let me walk you through it very practically. So ad tech as we know it today didn't exist 10 years ago. Ad tech 10 years ago was slap a banner ad and hope it's relevant. Today, ad tech is how do I keep track of everybody I know, and how do I track their behavior, build a profile, and then make sure that as I'm showing them banner ads throughout the day, that these ads are relevant to these users, because the only way I make money as an ad tech vendor is showing relevant ads and getting people to click on them. So the way our customers use our database is they write these very sophisticated applications, and those applications key on two data sets. The first data set is a Hadoop extract, usually almost always a Hadoop extract, where they build a customer profile and they say, hey, this customer, this is this person, and these are the characteristics of this person. And they take that Hadoop extract and they load it into Aerospike. And then over the course of the day, they watch people on the internet to see what they're doing. So if you are exhibiting browsing behavior that shows an indication of a certain interest in that day, they match that indication with your profile, and then they serve relevant ads. So very explicitly, if I go online, they have my profile and they see what I do during the day. So if I go to the Nike website and the Adidas website and the Puma website, they say, hey, Peter is a 45-year-old male. We know not only is he young and handsome, but he's athletic. So let's serve him some coupons for Sports Authority or Model Sports, because we think that based on his browsing activity, he's in the market for a new pair of sneakers or maybe a running shirt or something like that. So if you can write that application, and we provide you that data, and you can access that data in your application quickly, then you have a better chance of serving ads that have a higher click-through rate. Let me switch to another example, and this one probably resonates in a different way. Fraud prevention. We have a customer who you all know, but unfortunately we don't have their approval to share the name with you. But they needed to rewrite their fraud application because their fraud application as it existed was too basic, and they were having two big problems. One is they were having too many false negatives, which is even though you as a customer are submitting valid transactions, they couldn't ascertain the validity quickly enough, so they were denying transactions, which means that if you get enough denied transactions, you seek an alternative electronic payment method. So they were having customer churn based on too many false negatives. So in a legacy fraud transaction application, because you only have about 3/4 of a second to return an answer, you can't ask many questions. So you can ask things like, is this person current on their payments? Are they over their credit limit? Is the dollar amount below $25? Is it a vendor that they've done business with in the past? And if you meet that relatively limited set of criteria, then you approve or deny the transaction. But that's not enough. The opportunity now is because our analog behavior is replicated digitally now, we just know so much more, and the data exists to make so much more informed and accurate decisions. So this electronic payment provider said, look, I want to build a much more robust fraud algorithm, and not only do I want to ask things like, are they current on their payment, and are they over their limit, but I want to know what kind of IP, what their IP address is, what device are they using, is it a vendor we trust, is there something in their charging history that would indicate that this is a valid transaction? So this company replaced a very large legacy vendor, Aerospike, and a couple of our hardware partners, and they were able to write a much more robust fraud algorithm at a significant cost savings where they're now getting much more accurate readings. So their false negatives are down, their churn is up, and it's really helping them drive their business. So let me go to my last my last example, and this is Telco, and this one is a little bit out of left field. And when I heard this use case, I thought it was super interesting. So Alcatel-Lucent is a telecommunications services provider, and they write software that they sell to carriers like Verizon and AT&T and the guys you use. And if any of you have ever had the experience where you get a text some point during your billing cycle and it says, hey, you're about to go over your data usage limit for $15 to buy another gig of data. Do you want to do it? So you say yes because I don't want to pay the penalty. You spend $15, you buy the gig, and then it turns out your billing cycle ended 2 days later. Well, why do Verizon and AT&T do that? Is it because they're trying to maximize that $15? No, they're absolutely not trying to do that. But they don't have a application and a database supporting an application that can handle both the billing data and your usage data in one database to build an application on top of, because these are enormous data sets. So what Alcatel-Lucent has done is they've completely rewritten a new application that it combines billing and usage. So now when it looks like you're about to go over your data limit, they're able to ping you and say, hey Peter, you are about your billing cycle ends in 2 days. It looks like you're going to be about 50 meg over. Do you want to buy 100 meg for $2 just to make sure that you don't go over your limit? So they're combining usage, analytics on usage, and my billing plan. And $2 is much better for me than $15, and it's much better for the provider, because then I as a customer don't get upset for feeling like I was gouged with 1 day left in my cycle, and my churn goes down. So rather than maximize the $15 upsell every month, what they want to do is they want me to stay on their plan for 1 month longer, because my monthly plan is $150. So I've given you 3 stories on highest and best use cases for Aerospike and the kind of applications we support. And now I want to turn it over to Alvin Richards, our Vice President of Product. Let him walk you through a little bit of how we do what we do. And then I'll come back and tell you a little bit more about the verticals that we sell into, and then we'll go into a Q&A. Alvin?
Thanks, Peter. So let's talk a little bit about how this works. So ultimately, at its core, Aerospike is a key value store. And the innovation that we've really spent our time on is, it came from an understanding of how flash and SSDs work. Essentially, over time, flash can wear. If you apply variable workloads in terms of the data you write, flash can change its behavior and its latency response. So at the core of Aerospike, we have a structured file system that's optimized for flash. We work with all the flash vendors. And what this means to you is that we can eliminate all of the layers of the file system cache and operating system cache to ensure that we can actually drive your hardware resources, both CPU and IOPS at your flash device, to the limits. And so you can see on the picture on the left, essentially what we can do is we can blend DRAM and we can blend flash so that you are guaranteed persistence, but you get the lookup behavior of DRAM. On the right-hand side, so that's the kind of, that's the how we do it. On the right-hand side is the evidence. So you'll see some benchmarks that are run by Thumbtack, and you can actually see a comparison of mixed and read-heavy workloads, and what this means in terms of throughput and latency. And so this is kind of the fundamental parts of how we can actually get more out of your compute node. The second part is, how do we scale, right? We can do really well exploiting the hardware that you have at hand, but what happens when you want your second computer, right? So what we do underneath the covers at Aerospike is that we use RIPE-MD160, which is a collision-free hashing algorithm. And essentially what that allows us to do is to distribute the data across all of the available nodes in the cluster. On top of that, we can provide replication factors. So if you need 2, 3, 4 copies of the data, we can do that as well. And that's to ensure that you have the right data protection. You don't want to lose a node and lose data. You want to have multiple copies. So that's inbuilt and automatic into Aerospike. The key thing about our architecture is it's shared nothing, which means as nodes enter the cluster or leave the cluster, we can automatically rebalance and repartition the data around the available nodes. And so you can see on the right-hand side, as nodes come and go, we can actually maintain that cluster stability and the throughput and latencies. Clearly, as you add nodes, you have to move some data around, which is why you see some drop. But in comparison to the other NoSQL technologies out there, we can sustain the rates at a much higher rate than all of the other products in this space. So, okay, speed and scale, that's kind of awesome. What does this really mean to me? Why do you care? So ultimately what this means is, and we've got a real customer case here, what this means to you is that you can use 10x less hardware in order to sustain the same amount of throughput and latency as you would do in an alternative NoSQL database. The other way of looking at this is with the hardware that you've already purchased, you can actually get 10 times more throughput and do more work. What this means to you as an application developer and architect is you've got all the advantages of NoSQL. It's schemaless. It fits in with your agile development methodologies. You can change the schema on the fly. So you've got all the advantages that you'd expect out of NoSQL. But what this really means in terms of your deployment is that you can actually maintain your application SLAs. You can grow and shrink the cluster as you need to. And ultimately, it will allow you to build a richer, more engaging applications because you've got access to more data. You can process more data. And this is kind of what we see in financial services, ad tech, and telco, that having more access to a larger graph of data with extraordinarily low latency allows you to build engaging applications for your customers. Peter.
Great, Alvin. Thanks a lot. So let me just show up one slide where we can kind of give you a sense of our vertical focus and our horizontal opportunity. We've got a number of customers in ad tech, but we're doing a pretty brisk business in financial services and telecom as well. But of course, that's not exclusive to, or not to the exclusion of anybody in e-commerce and gaming and a variety of horizontal clients. So as long as the demand and the requirement of your application is speed at scale, it doesn't really matter what vertical you're in. So if I can just go to the next slide and recap what we think we've talked about today. Aerospike is focused on real-time, mission-critical applications, and we think our technology uniquely enables you to leverage speed at scale. We scale up and we scale out. We accelerate real-time applications. As I showed you in the customer list, it's retail, it's banks, it's telecom, it's ad tech, it's internet, and we can help you save money and be more efficient. So with that, let me just go to the last page and some resources for you to use as you're thinking about databases, and then I'll throw it back to Jane and engage in some Q&A.
Thank you, Peter, Alvin, and Noel. We've had some great questions come through while you all have been speaking. Please note that if you have any other questions, feel free to still continue to enter them, and we'll address them as I go through the list. The first question came through, Peter, while you were speaking. Somebody said, when you say you are 10x, what exactly is that in comparison to?
Yeah, we're not always 10x. We are occasionally 10x, but we can be as much as 10x. And what we find most frequently is there are IT departments that have built out Cassandra, built out a Cassandra database, which, as you all know, is a pretty popular open source wide column data store. And as they experience success with their Cassandra database and the data loads grow, these users are generally forced to buy a lot of hardware, because, as you know, one of the better use cases for Cassandra is scale, not necessarily speed. So when you're in a situation where you're successful with your Cassandra deployment and you model out your data center costs for the next couple of years, that's often a switching point where a lot of customers want to engage with us, not only to drive down their cost of hardware and their data center costs, but also to get some of the performance characteristics that aren't possible in Cassandra.
Awesome. Thank you, Peter. Another question came through and it said, all right, so if NoSQL is so great, then which bank or which airline is using it for its core banking or ticketing reservation system? Great question.
That is a great question. Increasingly, we're seeing Aerospike used, and I'll talk about Aerospike specifically, in mission-critical applications. So Peter talked about ad tech. We see other cases in travel, in telco, and in financial services, where if Aerospike is not up and running, then the organization cannot conduct business. And so whilst these are essentially new forms of use cases within those organizations. They're very similar in characteristics to those core banking and financial services systems, in that there is a need for extraordinarily high reliability and availability to the data. And that's a kind of critical phase of, the adoption of these types of technologies, and we believe that Aerospike has got some very unique qualities in order to make those successful.
It's Peter. Let me just add on to Alvin's answer. Believe me, we would love to tell you what financial service institutions are using us. That they won't let us, and that makes us really sad because they're great stories. But in the travel world, one of our big customers is Kayak, which you guys all know as the online reservation system that lets you shop prices across multiple airlines, so you don't just have to go to the American website or the United website. And the Kayak use case is really interesting. In the travel reservation world, the GDSs generate their fees by the number of times a reservation agent pings their data. So if Kayak were to ping the GDS every single time you wanted to search a flight, they would go broke. So what they do is they built a cache and they update that data on a regular basis. I believe in Kayak's case it's hourly, but it's not real time. So when you go to Kayak and you're trying to buy a ticket and they give you a price, that's a price that has existed within the past hour. But as some of you may have experienced, I know I have, sometimes when you go and buy that ticket, it's gone because it's not live data. So Kayak saves an enormous amount of money by caching that data. It's their operational database. It is their lifeblood to show you, their customers, what the prices are. And that is an enormous data set that exists in a cache. And we have a number of other caching use cases for data that is near real time, but doesn't need to be real time, but the data set is really, really large.
Thank you, Peter. So the next question is, does Aerospike plan in the near term on providing an Elasticsearch XDCR plugin?
Great question. So we believe in order to build great applications, we need to integrate well with the rest of the tools in the development chain or the tool chain. So we already have connectors for Spark and Hadoop, for JDBC, and we are working to extend that out. Elasticsearch is an obvious one, so is Kafka. And so I would expect kind of, news from that in the early part of next year as we extend out those plugins to broadly integrate with those tools.
Great, thank you, Alvin. And another question for you, does Aerospike require Flash or can it work with Spindle?
Absolutely. So we ultimately don't care where you store your data. You need something that's persistent and reliable. Now, the question is what kind of access do you want to that data? Do you care about how long those IOPS take? Do you care about the response time from the application to the database and back again? And that's when you look at architecting the right set of hardware profile in terms of flash, spinning disk, DRAM, and getting that balance right for the needs of your specific application. So the short answer is yes. The longer answer is, what do you really want to do and what do you really care about?
Great. So another question came in about, do apps need to be rewritten with the Aerospike API, or do we have plans to provide SQL-like stored process to migrate their apps easily?
A great question. So we offer a JDBC driver that's essentially meant for read-only type of queries. We're not expecting people to build applications on JDBC to access Aerospike. In reality, what you want to do is, as you're adopting an alternate NoSQL technology like Aerospike, what you really want to do is you want to think about your use cases and your data model and your data structure. Because you'll want to model data in a different way than you would traditionally in a relational database. In a relational database, you would normalize everything and then go through a process of denormalization. In Aerospike, you'd want to model the data that's appropriate for a key value store. And so ultimately, because you're remodeling the data, you're going to have to rework part of the application, and reworking part of that application is to make use of our client APIs which we make available for all of the popular languages, Java, C#, C++, Node, Python, and so on and so forth.
Great, thank you. Another question came in asking if Aerospike has a key watch notification mechanism if values change in the key value store.
Great question. And so this is all part of, it feeds into our connector strategy. It's key that you need the notification. Right now we have an internal pub/sub mechanism, and what we're working to do is to provide the hooks into the developer API so that you could be notified as well. Right now that's not exposed, but we have plans to provide that.
Great. And our last question for today is, how do you handle the write amplification problem of SSDs?
It kind of really depends on the specific form of write amplification you're talking about. So given the time that we've got, we could dive into and spend many hours just talking about this subject. I'm happy to follow up with the person asking the question. You can email me directly at alvin@aerospike.com. So Daniel, I'm happy to follow up with you on that one.
Great. Thank you, Alvin, and thank you, everybody, for your great questions. If you have any other questions, please feel free to email Alvin directly or email us at info@aerospike.com. You see some next steps here up on your screen, so please be sure to check those out. I'd love to say thank you to all three of our industry expert speakers, Noel, Peter, and Alvin, and thank you for a great webinar.